Hey guys, so today is Wednesday, and since we didn't have school yesterday, you have to do days 2 and 3 of our bell ringer. Our weekly question is, how does a wheelbarrow make work easier? The handles on a wheelbarrow are examples of a lever. Levers are commonly used to lift a load. A lever sits on a point called the fulcrum. So if you look down here, this is the fulcrum, where the lever pivots or moves. On the wheelbarrow, the fulcrum is the axle of the wheel. So there's the axle. When you push or pull down on the handle, it pivots or moves on the fulcrum to raise or lower the load. The positions on the fulcrum and the load change the lever's mechanical advantage and the direction of the force. There are 3 kinds of levers, depending on the position of the force, the fulcrum, and the load. When the fulcrum is between you and the load, pushing down will lift the load. Lifting up will lower the load. So you're going to push up and they'll go down. When the load is between you and the fulcrum, the load is easier to lift or lower, but the direction of the force does not change. So here we go. The load is between you and the fulcrum, and you lift it. When you are between the load and the fulcrum, a small movement in force causes the load to move farther. So here we go. There is an example. Type a sentence that explains how the lever in a wheelbarrow works, because remember, that's what we're talking about, wheelbarrows. Here is what I have. If you have something similar, leave it. If not, you can use mine. When you push down or pull up the lever, it raises or lowers the load. So when you pull up or push down, it raises and lowers the load. Name 4 examples of levers that you have seen or used. These are 4 that I put. If you can't think of 4, you are welcome to borrow mine. I have a door handle, much like the ones we have here at school, pliers, chopsticks, and scissors. Moving on to day 3. Wheel and axle helps you do work by changing a push or pull into a force that rotates or spins. With wheelbarrows, it's much easier to push a load rolling on a wheel than to drag the load along the ground. A wheel and axle also creates mechanical advantage. We talked about that last week. When the axle rotates, the wheel moves a greater distance than the axle does. For example, when you ride a bicycle, your foot turns the pedal, which is connected to the axle. The wheel moves more than your foot does, so you contribute less force to move a greater distance than you would if you walked. All right. So in A, you have to click and drag the arrows below the picture to point to a wheel and axle in each illustration. So one of your arrows could be pointing at this wheel, or this wheel, or even down here on this wheel. And the axle is in the middle. Here on this Ferris wheel, the outside is the wheel. Or you could have even said this part was the wheel. And then the mantle right there in the middle, that is the axle. On the wheelbarrow, the black right here, that is the wheel. And then on the inside right there is the axle. On B, you had to click and drag true or false next to each statement. A wheel and axle can create mechanical advantage. That is true. In a bicycle, the wheel moves a shorter distance when more force is applied to the pedal. That is false, and it gives you the example up here at the top. All right. In each example below, tell whether the force applied is directly to the wheel or axle. So a faucet handle, you're taking that straight to the wheel. We're talking about the faucets that turn. Not necessarily the ones with the lever, but we're talking about the ones with the circular turning. Number 2, a spinning top. That is an axle. A steering wheel is a wheel. An airplane propeller is an axle. If you have any questions, let me know. Otherwise, have a great Wednesday.